Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. We're going to get started. This is day 3 of our online 1-hour training sessions. So what we're going to do today is we are going to go through a group of different tunnel modes. So we're going to talk through the bridge tunnel mode, routed tunnel mode, IP share tunnel mode, and we're also going to discuss the FastLink tunnels. In addition to that, we're going to go through some IP filtering and a couple of other features within the device just to make sure that everybody understands the capabilities of the devices. So the first thing we're going to do in section 1 is we're going to review, we're going to talk about a bridge tunnel mode app that we have online. We're going to walk through some bridge tunnel operations, walk through some configurations, and we're going to discuss one of the applications that we have. So we have a website that is doccentrial.iptechnologylabs.com. It has user manual information. It has app notes. So within this section, as we're talking about these different pieces, I'm adding in these different app notes. So there's a really good bridge tunnel app note that kind of walks you through. I think the heading on this slide is wrong, but it's a bridged app note, and it walks you through step by step the configuration for both ends of the link. Conceptually, with a bridge tunnel, what's important to understand is that any of the interfaces that are attached to the system bridge all have access to each other, as long as they're not filtered. Now, you can filter out any of the interfaces, or you can filter IP addresses, a lot of different things you can filter within the devices. But all of the interfaces that are connected to the system bridge can all communicate directly with each other as if they're on an Ethernet switch. So if I have on my left side a local Ethernet port connected to my system bridge and a tunnel connected to my system bridge, that tunnel makes a link to a remote device, which is connected to the system bridge, and then another Ethernet interface connected to the system bridge. This address 192.168.101.1 is accessible on both sides of the link. So if I have a laptop on, it doesn't really matter where that actual IP address lives, what the device is. Anybody on either side of the link can access that IP address. So the networks basically operate as if they were connected by an Ethernet cable over the internet. So typically the server is installed in stub mode, and stub mode we discussed last time. It's a single Ethernet connection onto the network. And so internally what that looks like is you have your encrypted traffic for your tunnel on the Ethernet interface, and you also have your non-encrypted open traffic on the same Ethernet interface. So tunnels come in, traffic gets decrypted, gets dropped onto the network. Traffic that needs to go across the tunnel comes into the device in the clear, gets encrypted, gets sent over the tunnel to the remote network. So not every server installation is set up in stub mode, but that's most common. But I don't want you to feel like you have to set up your servers in stub mode. But typically when we are allowing access to a server network, the devices are set up in a stub mode. And kind of the benefit of the stub mode, one of the things that works really well with that, you don't need to do any rewiring. You don't need to make any big changes on your server side network. Keep your same router, keep your same DHCP server, everything else. You can plug the device into one open port on that network, and then that device is accessible as a server to provide access to that network. Client side is typically installed in an inline mode. So on the left side, we're looking at the client device. Now, again, it's not mandatory. It doesn't have to be that way, but just a typical installation, the client is installed in line with the network. So he has an uplink Ethernet interface that's detached. So this interface connects to your network router. He gets an IP address, a gateway, DNS servers, and then he uses this interface to create his tunnel to the server. The local side, you have your network connected to the local side. Traffic can get bridged from the local to the tunnel interface and go to the remote network. You can access the system ID from either side, or system IP address from either side, either the local or through the tunnel. This device can be the DHCP server for the network. They can run in compulsory tunnel mode or split tunnel mode. So all that operates the same. The basic concept with the bridge mode is that you're extending the network using essentially an Ethernet cable over the internet. So we have three different networks. We have a head office and 2 different remote networks. We have a single flat /24 Ethernet address space, and you'll see this change as we go through from a bridge mode to a routed mode to an IP share mode. So in this situation with a bridge mode, these 3 networks are all essentially connected together using an Ethernet cable. It's actually a secure routed tunnel, but you can think about it in terms of the bridge mode being like you're connecting these networks together using an Ethernet cable. So conceptually, I wanted you guys to understand the operation of a bridge mode, the fact that it's like connecting networks together using an Ethernet cable. There's an app note discussed in this document, and that app note would allow you to take your units and go step by step and configure a bridge tunnel point-to-point network. So the next section we're going to discuss is a routed tunnel mode. A little bit different than the bridge. A routed tunnel mode, you can set any of the devices for a bridge tunnel or a routed tunnel. When you set the device for a routed tunnel mode, it's going to operate a little bit more like a traditional IPsec tunnel. So we're going to talk about the server-side config. Now in this section, we are going to go through some configurations and talk about how we configure the devices. One of the things that we did with our routed tunnel mode setup is all of the configuration is handled on the server side in terms of the routing. So on the server side, you're going to set up your server-side routes, your remote routes, everything, and then the devices will push that information over the tunnel. So we're going to talk about the routed tunnel app note. There's a couple of different app notes on Techncial that go through the routed tunnel mode in very good detail. We're going to talk through the configuration, how you set up your routed tunnel, and then we're going to discuss some typical applications. So Techncial has a routed tunnel app note, does a really good job of walking you through the configuration options that are available, both on the server side and on the client side, discusses, any routing that you would need to set up on your own network. So in a routed tunnel mode, we're going to have 2 different networks on each side of the link. So on the server side, on the right, we have a 192.168.101 network. And on the client side on the left, we have a 192.168.10 network. And what we want is the client device to understand how to route traffic to the server network, and the server network understand how to route traffic to the client network. So we have basically what the devices do is they send up an intermediate IP link over the secure tunnel. Server side by default is 10.0.0.1. And we can assign different IP addresses to the remotes based on the system ID of the remote device. So you can see we have a couple of little routing tables down here. You can see he understands that 192.168.10, which is the client network. He will need to send that traffic to 10.0.0.20, which is the IP address on the tunnel link. He also has a 192.168.101, which is his local network. On the client side, he has a 192.168.101 network, which is the server-side network, and he has a gateway of 10.0.0.1, which is the server-side's internal IP address. Now, this route you don't add directly onto the client device. You configure this information on the server, and when the tunnel is established, the server will send that information to the client device. So server-side configuration, we're going to break this down and go through it in a little bit more detail. But when you log into a server device, you get information on what devices are connected, okay? When you change your device to routed tunnel mode, you'll get another set of options. If you were in a bridge tunnel mode, you would see this client connection, and that would be all you'd see. You wouldn't see these other options. As soon as you switch your device to a routed tunnel mode, these additional options for configuration will pop up. So on the server-side network, we're defining our tunnel interface IP on the server side, so 10.0.0.1. We're defining IP addresses for our remotes. Now, the important part here is this server-side network block. We are saying 192.168.101/24 is a server-side network. So on our server-side networks, anything we define as a server-side network, the server is going to push that information to the clients so that they understand what networks are available on the server side. So I could have 10 different networks on my server network, and the server device will push all the routing information to the remote device. So this is how the server-side networks is how we inform the client what networks are on the server side. Our client-side networks, we're informing the server what networks are out on the client-side network. So in this case, we have the system ID or MAC address of our client device. So there's a little block here for add a new client. We put in his system ID. We define the interface IP address. So we're giving him a 10.0.0.10, and we're defining what his remote network is. This tells the server, if you receive traffic for 192.168.10, we're going to forward that to 10.0.0.10, because that remote device understands how to route that to the end NPC or server. Now within here, we can go in and add multiple networks for the client. We can also assign metrics to it. So I can have 5 different networks on this client-side device and have all 5 of those listed in here. And that tells the server, if you need to reach any of these networks, just forward that traffic to 10.0.0.10 and the client device will take care of it. So our server-side configuration, we're going to go in and set it for routed. We define his interface IP address, okay? And then we set up a default IP addressing for remote devices. And what this allows us to do is, if we haven't configured the client-side device, he will get an IP address out of this range. It's sort of like a DHCP for the tunnel interface. The server-side networks, we're going to define the networks which live on the server side. And these routes, this information, the networks that we put into our server-side networks will get pushed out to the client device, and the client device will install route in his routing table. So we define the server-side networks, the networks that live on our server side, and then in the client-side routing table, we'll get this network and an interface, which is the tunnel IP address of the server. So now on the client device, if he receives a packet for 192.168.101, he knows to forward that to the server device through the tunnel. To create our clients and be able to find what networks live on the client, again, this configuration is all done on the server side. We have an add new client. We put a system ID in here. Once you put the system ID in, you get a new block of information here. Oh. Sorry about that. Once you put in the system ID, you get a new block for that client device. And then you define a unique interface IP address that we can route to. And then you can put any number of remote networks and tell the server, these are the networks that live on that remote device. So now once I set this up, my server-side routing table has a 192.168.10, and he knows the gateway is 10.0.0.10. And you send the traffic intended for 192.168.10 to this interface IP address through the routed tunnel. On the client-side device, it's much simpler. We set the tunnel mode to routed. Once the tunnel gets established, this IP address will be given to him from the server-side network. So on the server, we define that client. That gets pushed to him. He'll get all his routing tables. He'll also get his interface IP dynamically from the server-side network. So typical application. We have one remote network, 192.168.10. We have a network 192.168.22. We have a head office network of 192.168.101. We define internal tunnel IP addresses. All the configuration for routing is set up on the server side, and he pushes that information out to all the clients. And we talked about in our last session, the tunnel configuration has a client-to-client setting, which basically means, can the client networks see each other? In a routed mode, if we have client-to-client enabled, then this device will also get a route on how to get to the 192.168.10 network. And this device will also get an additional route on how to reach the 192.168.22 network. So that's just a note that I wanted to throw in there. So that is the basic concept of the routed tunnel mode. One of the important things that I did want to point out is on our Techncial site, I gave the link to this, and I just wanted to show you how this works. So operations, functions, and features, we go into a tunnel, and we get routed tunnel mode operation. So this app node is really good. You can see we set up routing tables, and we set up a typical point-to-point routed network. Talk through what the client-side routing looks like, how the tunnel interface IP is established. We talk about inline mode, stub mode, and all of these have, it sort of breaks everything down for, here's my local interface, here's my uplink interface, here's my tunnel interface. And this router that you see here is the internal router on the device. And it shows how these IP addresses are established and where they're configured. Goes through some configuration on setting up your device from a starting point of a default device. So here we set our tunnel mode from bridge to routed. We set up our server IP addresses, set up the IP address, or set up our listening ports, how to create this client-side device and how to set him up. So these app notes do a really good job of sort of walking you step by step through this configuration. The next section we're going to go through is an IP sharing. And so we have discussed bridge tunnel modes, we've discussed routed tunnel modes, and now we're going to talk about IP sharing, which is sort of a mix of the two. To really understand IP sharing, you're going to really want to go back through this document. I think these were sent out last night. You're going to want to go back through this document, read it, look at each of the diagrams. IP sharing is a very, very powerful mode for setting up your devices. It's unique to IP Technology Labs. It solves a lot of problems in remote networking. But conceptually, when you first look at it, it's a little difficult to understand. There's a lot of network interfaces. It's very easy to set up once you understand it conceptually. So once you understand it, it's a very easy configuration. It's a really easy configuration to set up, and it's extremely powerful, but you sort of have to understand how the internal pieces fit together. So we're going to talk through IP sharing, benefits, what you get by using an IP sharing. We're going to discuss some typical applications, how the networks are put together, and how the packets are routed. So IP sharing provides a way of hiding a remote network. It also allows you to access the remote network based on an IP address from your server-side network. It sets up a routed tunnel mode without having to set up any routing on either side of the network. So this is what an IP share network looks like. On the right side, we have a server network, 172.100.1. We have a remote network. And so we have our device, our client device is set up inline. On his uplink IP address, we have a 192.168.10 network. On his local side network, we have a 192.168.1 network. And then he gets a tunnel interface IP address, which is part of the server network. So this can be statically assigned or dynamically assigned using DHCP. The key point here is this device, when you use IP sharing, the remote device turns into a 3-port router. And we're going to break this down into detail and walk through this step by step. But what you really want to understand is I have a local side network, 192.168.1. I have an uplink network, which is connected to my ISP. So if we want to run in a split tunnel mode, this is where all my traffic that's not intended for my head office is going. It's going out my uplink through my ISP to the internet. And then if I want to access the server-side network, I have an interface with a 172.100.1 network living on it. So let's break this down kind of step by step on the client side. So we install a device, it's inline, we have an uplink IP address connected to our router. We have a local side IP address. We can set up a DHCP server on here. We can set up, split tunneling, IP filtering. This is a typical 2-port router like you would see on any other 2-port routing device. I have an uplink IP address. I'm routing out my uplink. I have a local IP address. Now we go to establish our tunnel. When our tunnel is established, we're setting the tunnel interface for a bridge mode, but we are detaching the tunnel interface from the bridge. So it's a routed interface. It basically looks like, to the device, it looks like just another detached Ethernet interface. When this tunnel is established, he sends a DHCP request through the tunnel to the server-side network. He receives an IP address from the server-side network, and then we apply NAT to that. So what you end up with is a 3-port router, 192.168.10 on the uplink, 192.168.1 on your local side, and you configure those. Your tunnel is established, sends a DHCP request to the head office, and he gets an IP address from the head office network. You can statically assign it, or you can do DHCP, but it's an IP address that's part of the head office network. So what this gives you, we add in our server side, say we have a laptop over here on the left side, 192.168.1.15, and he wants to send traffic to 172.100.1.100. What happens is the packet comes to the device. Because the destination address is 172.100.1.100, he sends it through his tunnel interface. We NAT the packet as it goes through. So the server-side device receives a packet with a source address of 172.100.1.20. So we don't have to set up any routes. The device on the server side receives a packet which to him looks like a local IP address. He receives the packet, responds to it. The packet goes back through the tunnel, goes back through our NAT, and we reverse the NAT gets reversed, and it goes back to the device that's on this local side. So we have a laptop, 192.168.1.15. Everything within the box is our IpTL device. We want to route traffic through the 172.100 network. So we want to route traffic. We want to send the traffic to our head office network. The packet gets routed through the tunnel, gets NATed. So the head office sees traffic from a 172.100.1.20 IP address. So on the server side, you're not putting any routing on the server side. Your server side IpTL device is set up in a bridge mode. Everything that he sees looks like local traffic, even though it's really coming from a network 192.168.1.15. To set up IP sharing, you set up a standard bridge tunnel, just like we would any other bridge tunnel. And then there's an IP sharing page. We detach, we apply NAT. We can set it for DHCP, or we can set a static IP address, and he'll send that traffic through, he'll send his DHCP request through the tunnel and apply that to the IP address or to his interface. So just kind of a review of this. 3-port router. One of the interfaces is connected to a server-side network. The server-side device, this shows him in a stub mode, but the server-side device is in a bridge tunnel mode. And then our client-side device, we're not setting it for routed, but because we're detaching the tunnel interface, it becomes a routed interface. So like we talked about in the last session, your local Ethernet interfaces are all attached to the system bridge. You can also detach your local Ethernet interfaces and give them their own IP address and their own gateway. It's the same concept here. We have a bridge tunnel. We're detaching that interface from the system bridge, giving him an IP address or getting an IP address through DHCP server to the head office network, applying that IP address to the tunnel, and we have a 3-port router. And really the big benefit here is that our server-side network, all the traffic that he sees is local, even though it's coming from the actual PC that's sending the traffic is a 192.168.1 network. So benefits of IP sharing, we talked about hiding remote networks. So I can have 2 different remote networks. that are 192.168.10. You know, these networks can have overlapping IP addresses between each other. I can have, you know, a printer on both networks, 192.168.10.100. I can have a database on both networks, 192.168.10.101. When we are communicating with the head office network, all the traffic at the head office looks like it's coming from the 172.100.1 network. So, you know, situations where we have IoT installations, where we're installing devices on people's home networks, and everybody's cable modem by default has the same IP address range. This is a really good way of sort of hiding the actual remote IP address. If you want to go from the head office through this interface and talk to specific devices, you can set up port forwarding rules on these interfaces to allow traffic from the head office to go into that local network. So IP sharing provides a means of hiding remote networks, because really what the head office network is seeing is the interface IP address of the tunnel. It allows you to access the remote network using a dynamic IP address. So the head office network didn't need to know that the remote network was a 192.168.10 network. All he needs to know is that 172.100.1.200 is the IP address of that remote network, and then he can access that remote network through that IP address, which is part of the head office network. So we're getting a routed tunnel set up without setting up any routes on the server side, or really any routing on the client side. So when we do duplicate remote networks, like we talked about, we can set up port forwarding rules to allow us to go back through the network into the local device. So it's a lot of information for a 1-hour presentation. It's a very powerful tool to use, the IP sharing setup. You're definitely going to want to walk back through this. There's also some really good IP sharing app notes on Techncial, which gives some additional information or breaks down these IP addresses and how this all fits together. So far we have discussed bridge tunnel mode, routed tunnel mode, and IP sharing. The next thing that I want to go through with you is IP filtering. The IP filtering in the device is very powerful. There's a lot of things that we can do with the IP filtering. We've tried to make it as intuitive and as simple as possible. So when you log into the IP filtering webpage, you'll see a group of blocks and you'll see blue arrows. The blue arrows indicate how traffic passes through the device. So the first set of rules that it's going to see is this input block. The second set of rules it's going to see is this block paths. And the third set of rules it's going to see is the static rules. There's a really good documentation on IP filtering on the Techncial website that'll walk you through all this. But the important thing to understand, the two key concepts here. One, these rules are all for user traffic. It's all for bridge traffic. So when you set up these filtering rules, you are setting up rules against bridged interfaces. And then there's another page within the device to set up filtering rules, SNAT, DNAT on routed interfaces. The other thing I want you to understand is, as you look at these blue arrows, if we drop a packet in the input path, it's not going to be seen by the static rules. So when you drop it, the packet is dropped. So within the filtering, we can filter on a lot of different options, from IP destination, source and destination IP address, interfaces, port numbers, MAC addresses, VLANs, everything in layer 2 and layer 3. When we get into the routing, we can also filter based on layer 7, string matching, and things like that. The IP filtering is based on these hooks on the system bridge for this first section. So you can filter on any interface that is attached to the system bridge. So if you take a look at this, the bridge understands, the system understands what interfaces are attached to the system bridge. So right here, we've got local Ethernet 2, 3, 4, and 5. They're all attached to the system bridge. So I can set up filtering based on those interfaces. If I go to this Ethernet interface and I detach it from the system bridge, then when you look at your drop-down box, there's no more local Ethernet 2. It's no longer available because now it's a detached interface, and now you would go to your route filters to set up filtering based on your detached interfaces. Traffic passes through the device just like it shows in the blue arrows. Within the input paths, there's also a special feature called a redirect. So conceptually, let's say we set up a compulsory tunnel mode, and we have everything going through our tunnel to our head office, and if it needs to reach the internet, it goes out the internet ISP at the head office network. But let's say I have one laptop that's just running Pandora. It's just running, a streaming service, and I don't want that going through the tunnel and out through the uplink at the head office. We can redirect it. So when you redirect traffic, you're taking traffic that would normally be in a compulsory tunnel mode, you're redirecting it out the local ISP and making that a split tunnel. So you can set up your device where, hey, I want all my web traffic to go out my local ISP, but anything else has to go through the tunnel. Or I want, this set of PCs, anybody with this IP address, I want them to be in a split tunnel mode and route it out through the local ISP. Everything else should be in compulsory mode and go through the tunnel. The blue arrows show you how packet flows through the device. If a packet's dropped, it's dropped. If it's accepted, it's accepted. So you can see here, we've got a packet that's been accepted. So we've got data coming in the wireless interface, and we're allowing it. And then we've got our second rule is data coming in the wireless interface, we're blocking it. Because we are allowing it here, that packet has been accepted, and it will not be evaluated by this block. And you can see the ICMP packets are all working. And this goes through the different blocks. So if I'm blocking traffic on my input filter rules, when I get to my static filter rules, you'll see there's no counters here because the packet's already been dropped. We can insert rules in line. So if I've got a set of filter rules and I decide I need to have something in between these two, there's what we call an at location. And we say, I want this new rule to be at the new location of 3. And I add my rule and it inserts it into the spot on 3 and everything else gets pushed down. We can delete individual rules. So I can go in and just check box which ones I want to delete, say delete those rules. And we can clear the counters. And this is great for troubleshooting where I can go in and I've got a bunch of different rules. I've got all my rules set up the way I expect them to operate. I clear my counters, everything gets reset back to 0. And now I can watch my counters increment as packets are flowing through the device to try and get a sense of, hey, this packet should be allowed or this packet should be dropped. Where is it ending? And then we can also flush our tables. So I have a whole set of rules that are all set up. I can just flush them, wipe them all out. You can also, one thing to keep in mind is if something's not operating correctly, I can save my config with all these rules. I can flush the table. If everything starts working, I know it's a problem with my rules. If I'm still having the same issue, I know it's not a problem with my rules. I can reboot the device, and then I'm back to having my full set of rules. We have the ability to put in an invert. So these little exclamation equal means invert. So I can say source address is not equal to 192.168.10. So if I only want to allow traffic from one network to go through the tunnel, I can say anything that is not equal to this network, drop it. I can say anything that is not equal to port 5150, drop it. So kind of walking through each of the paths relatively quickly. The first thing we come to is the input paths. This is blocking traffic as it enters the device. So all of the other rules evaluate traffic as it's leaving the system bridge. And the reason for that is if you want to block based on, I want to block traffic coming in the wireless interface and out the tunnel interface, you can only evaluate that as it's leaving the bridge. It needs to know what its output interface is. So the input paths is a way of blocking traffic at the input interface. So I can say I want to block traffic right as it comes in my local Ethernet interface if it doesn't meet this certain set of criteria. So this input paths operates directly on this internal filtering block as the traffic enters the device. Block paths is probably the most common used, and kind of what we try to do here is set up the most common filtering requirements. And we set this up so you don't have to remember what your DHCP port numbers are, and you don't have to remember your different interfaces. So I can come in here and I just say, I don't want any traffic going from my uplink port to my tunnel. I don't want any traffic going from my local port to my uplink. And I don't want any DHCP going through the tunnel. So by checking these, we block them. And then when you submit that, we automatically create the actual rule set and we list them out so you can kind of go through and review, yes, that's actually what I did want. I want to block based on these port numbers. Static rules allows you to start setting up source and destination interfaces. So within the static rules, there's 3 different blocks. We can filter based on IP filter rules. So source, destination, IP address, IP packets, interfaces coming in and out of. We can also filter based on VLANs, both the VLAN ID and the priority. And then we can filter based on very low level MAC addresses. So this is how you would go through and say, I want this one specific PC to be able to get to this interface. I can filter based on MAC address and source IP address. Common attacks and limit data, those are discussed online. We don't see a lot of usage. We don't see a lot of people using those. They're usually just left to the default. So we're going to skip forward to the stateful packet inspection. So stateful packet inspection and static rules are very similar. The difference is the stateful packet inspection allows you to evaluate traffic based on, your packet operation. So I can filter new connections. So any new establishment of a connection, I can accept traffic that's established and related if it's already been configured. And so it gives me the state of that stream or the state of the packet, and then also IP address, source and destination ports, things along those lines. The default rule block allows you just to completely shut off an interface based on filtering. Within the web pages, we also have, so when you come in here, you'll see each of these that we've just discussed are listed here. We also have the ability to list all the rules together. And then down the left side, you'll see the blue arrows, which indicate the flow of traffic through the device. So now we're going to talk about routed interfaces. So a detached uplink, a detached tunnel, a routed tunnel interface. If I take a local port and I detach it. So you'll see here, there's 3 different sets of rule blocks. So input is anything that is destined for the application on the device, so the tunnel, web interface. Output is anything coming from the device itself. And then the forward block is for traffic that is being routed through the device. So if I'm in a split tunnel mode, or I'm operating like a router and I'm routing traffic from my local port to my uplink port, I would put these rules within my forward filter set. And then you can see here, the bridge rules that we've already talked about is another layer sort of below it. So the bridge rule, filter rules that we discussed are all operating at layer 2. The routing filter rules are operating at layer 3. And you can determine whether you're handling traffic coming into the device, going out of the device, and that's actually talking to the applications on the device, or we're routing traffic through the device. So this just gives a little bit more detail on each of the different blocks. So input block is traffic that is talking to one of the applications on our device. The forward block is traffic being routed through the device. The output block is traffic that is being sent out from the device. We have rule targets, so we can allow traffic, block traffic, just like we talked about previously. We can also mark traffic, and marking traffic is assigning a number to a packet, and that's metadata information that travels with the packet. It's only internal to the device. So you can't mark a packet, send it to another device, and evaluate that mark. But what you can do is, as a packet enters the device, I can mark it because it's coming in a certain interface, or it's using a certain IP address or it's coming from a certain VLAN. I can mark that traffic, and then later on within the device, I can evaluate based on those marks. So if I have traffic coming from multiple different interfaces and I'm looking for specific things on those interfaces, I can mark that traffic and I can treat those things differently. The biggest thing that marking packets is used for is you can mark your tunnel packets. And then when we get into virtual routing, you can, when we get into the virtual routing rules, you can say, I want, tunnel 1, which is marked with 1, that's going out ISP number 1. Tunnel 2 is going to be marked with a 2, and anything that's marked 2 goes out ISP number 2. Source NAT and destination NAT is basically just allowing you to, source NAT is what you think about when you think about a typical NAT router for changing the source address of the packet to match our interface IP address. Destination IP address allows you to redirect traffic. So I can have packets coming in destined for a DNS server. I can DNAT it, which changes the destination address, and I can DNAT it to a local DNS server. And then the packet gets routed, and everything gets routed to that local DNS server. So DNAT is a way of changing the destination IP address within a packet. You can also set up rules and send them to the NetFlow engine. So within the tools section, you set up your NetFlow. And then to understand what traffic you want visible by NetFlow, you can set up rules. So I can say, I want my NetFlow engine to see all traffic with port 2000, or I want my NetFlow engine to see all traffic coming in this specific interface. So the way that we have our NetFlow engine set up is we are directing traffic to the NetFlow engine, and then the NetFlow engine is handling all the NetFlow internals. So with the bridged filter rules that we discussed, typically that is all against user traffic going through the device. The route filter rules are actually, you can block traffic going to your web server. If you're working on a remote device and setting up some filter rules, you could lock yourself out of the unit. So let's say you were set up you only wanted a certain number of IP addresses to be able to access the web interface on the device, and you want to lock it down, and you don't realize you're actually coming through a different path, and you lock yourself out. So anytime you add a rule on the route filter, there's a little block that comes up and says submit to confirm new rules. So you're accepting the rule. So if you locked yourself out of the device, you would not see this pop up. And then after a 30-second timeout, it flushes the rule table. And that's basically just a precaution to make sure that you don't lock yourself out of a remote device that has nobody working there. So a couple of quick examples, and we're going to walk through these relatively quickly. You can go through these documents and take a look at them in more detail. So I can block incoming DHCP requests coming in over the tunnel, but allow outgoing DHCP requests over the tunnel. So we are filtering traffic coming in the tunnel interface with a source IP of 68 and destination IP address of 67, which is our DHCP packets. I can allow a DHCP request to go out the Wi-Fi, or to come in through the Wi-Fi and out the tunnel. And then I can also set up a MAC address to say, so coming from the local interface to the tunnel, allow this source MAC address. But then we're going to block everything else from the local interface to the tunnel. So we're only allowing this one device to go through the tunnel. Later on, if I decide I want another device going through the tunnel, I can insert a new rule, the new source MAC address, and have that additional device being allowed to go through the tunnel, and everything else is blocked. This is a really good example where we start talking about the redirects. So we can create a rule to allow ICMP packets, and this is one of the ones that we do in the 3-day training. And then ping 8888, see the counters going. We can insert a block rule in line from the PC and see that it's getting blocked. We can flush our table. And then in the actual training, what we do is we have tunnels that are set up in a compulsory tunnel mode. So all of your traffic is going through the tunnel. Then what we do is we set up a redirect, and we say anything with a destination IP address of 8888, that's ICMP traffic, we are going to redirect into our system interface. So what this does is all of your traffic is going through the tunnel in a compulsory tunnel mode, but if you ping 8888, it goes through the local ISP. It gets redirected and essentially puts it into a split tunnel mode. And what we do with what we do in the training is we do a compulsory tunnel mode. You do a what's my IP address. You see that the rest of the internet sees you coming from the ISP at the head office. Then we set up a redirect. Then we set up a redirect. And we set up a redirect, and you do a what's my IP address, and you can see that you're coming from the local ISP. So here we're kind of doing an example where we say anything that is not equal to 192.168.101, we're going to block it. And then you'll see the exclamation point here. And what we're saying is we only want traffic going through the tunnel that's part of our 192.168.101 network. We don't want the head office seeing any of the other networks that are on the remote device. So kind of a quick walkthrough of IP filtering, just some of the highlights. You do some very complex things with the IP filtering section, but we have put a lot of effort into trying to make it as simple as possible and as intuitive as possible to see how the traffic is passing through the system and where you are actually filtering your traffic. So the last section that we're going to go through, and this is a very short section, is our FastLink tunnels. This is relatively new. We developed a new set of tunnel technologies that operates exactly in the same, it has all of the same features as our standard TLS tunnel. It's really good for data backup applications, high-speed links, things along those lines. There's some really good documentation. It's been really well documented. You can do everything that you can in a standard tunnel. So you can do a bridge tunnel, IP sharing tunnel, routing tunnel. You can run the devices inline or stub mode. So just kind of talk through the features as we're launching this out and introducing it. It was added in the 4.3 release. So if you have an earlier version of code, you won't see the FastLink tunnels. Supports bridged, IP share, routed. It is 2 channels, so there's a control channel and a data channel. Just like in our devices now, the server side controls all the routing for the remote devices. Supports a bonded client failover, supports real-time resource. Each of the interfaces, so some of the things with the FastLink that we don't have in a TLS, when on a TLS tunnel and our standard tunnel on a server, there's a single tunnel interface. So when you go to filter, you're filtering based on that single tunnel interface. With the FastLink tunnels, each client that connects has its own unique interface. So I can filter traffic based on that tunnel at the server side device. The other thing is I can run a bridged and routed connection at the same time. So you're always, when you do a FastLink, you are always running a routed connection, and then we are running a bridged interface over top of it. So I can set up a link where I'm setting up routing between the 2 devices, and then I'm also bridging it. So a typical application for that is I've got my VoIP traffic is all bridged over my tunnel link, but then my data traffic is all routed over my tunnel link. So I can have, you know, one Ethernet interface that's for my VoIP network, and that traffic is bridged, goes to the head office, and then I have my other Ethernet interface is a routed Ethernet interface, and I'm routing traffic to the head office. And I can separate those 2, but all the traffic is going over a single tunnel to my head office server. Email notification is built in for secrecy, black noise, which is an obfuscation, tunnel authentication, everything that you would have in our typical network. And then in our hands-on training, our 3-day training, we actually go through, set up some FastLink tunnels. We do a bridged and routed connection on a single tunnel interface. and then we go through the status information and things like that on the FastLink tunnels. So that is everything that I had for today. In terms of day 3, the 3-day sessions we're doing monthly, so we'll have another one in September. Please go through the slides that were sent out. If you have any questions, please email us with questions and we'll go through and answer all your questions. And that can be questions on things that are in the slides, that can be questions on applications, that can be questions on demo installations that you want to work on. Feel free to send those questions in and we'll go through and evaluate them and give you some information back, point you to some app notes or send you some details on how the applications operate. So thank you very much. Everybody have a very good afternoon.